when I'm teaching you guys, I'm not caught off guard when it comes to knowing tables. Okay. So today what we'll do is we'll spend initial 10-15 minutes to do a recap of what all tables we know and come up with our strategy for getting better with tables, and then we'll pick up a topic for today. Alright? Make sense? Let's see who all knows what all table. And again, if you have not been in touch, you have not been practicing tables, it's not a crime. We will find out our ways to memorize them. Okay. In this class, you have the opportunity to make mistakes when it comes to solving problems. Don't make mistakes which are not acceptable, like disturbing the whole class. Alright. So let's start. I will call out the names. Nobody should start jumping and raise your hand. I will call out the names. Okay. Dikshita, are you ready? Table till
13.
13 6 ja.
78.
12 9 ja.
108.
7 9 ja.
Wait, what?
7 9 ja.
63.
12 8 ja.
96.
13 5 ja.
65.
Good job. So you seem to be knowing it. What you were lacking was, it was when I was asking you numbers, you were saying 13 5 65. You had a little bit of doubt in your mind. Take that out. And how you can do that is by spending 5 minutes of your unproductive time every day. It just takes 5 minutes. Okay. Whenever you are getting bored, you are trying to figure out what exactly you want to do next. Use that transition period for memorizing tables. Okay. It just takes couple of minutes. Let's say if I have to memorize table of 12 and 13, this is what I'll do. 12 1 is 12, 12 2 is 14, 24, 12 3 is 36, 12 4 is 48, 12 5 is 60, 12 6 is 72, 12 7 is 84, 12 9 8 is 96, 12 9 is 108, 12 10 is 120. It took me less than a minute. Then I'll pick up 13, 13 1 is 13, 13 2 is 36, 26, 13 3 is 39, 13 4 is 52. Likewise, I'll go on. It takes me less than 2-3 minutes. You can keep 2 minutes extra because obviously I've been memorizing it till now, so it might take a little bit more for you, but yeah, not more than 5 minutes for sure. And keep questioning yourself, keep playing with it. Catch hold of somebody, okay, saying, okay, fine, ask me table 13, let's see if I remember. I know Dikshita, you have a sister, right? You can ask her, okay, ask me questions on table 13. Let's see if I'm forgetting something. And if you forget, don't worry about it. Forgetting is fine. You're just checking whether you are in touch or not. Okay, that's what we'll do. Okay, let's go to Anirudh.
Tables until 12.
12, okay. 12 6 ja.
Wait, what did you say?
12 6 ja.
72.
8 9 ja.
72.
9 9 ja.
81.
12 6 ja.
Say that again?
12 6 ja.
72.
11 9 ja.
99.
12 9 ja.
108.
11 9 ja.
99.
9 9 ja.
81.
Good job. Thanu, table till
12.
12 6 ja.
72.
9 8 ja.
72.
7 7 ja.
49.
12 9 ja.
108.
13 3 ja.
13 what?
13 3 ja.
39.
That was a surprise question, but yeah, good job. All right, so keep, even if you think you're champion, no harm spending those 2 minutes. Okay, let's go to Lakshita. Lakshita, ready?
Yeah.
Table till
12.
12 8 ja.
96.
9 7 ja.
63.
11 7 ja.
77.
9 8 ja.
72.
6 7 ja.
42.
Good job. So keep revising table till 12, at least for next 1 week. Spend 2 minutes every day because you already know it, but just make sure that you are super accurate, super quick with your responses. That will help you play with maths. And then after a week, maybe you can switch to 13. Okay. Let's go to Praneeth.
So I haven't actually memorized it until like over 10 because like I didn't really go ahead of 10,
Okay.
but I know it all the way until 10. Yeah.
What is this style? Are you doing pushpa?
He's doing mewing.
Are you guys doing pushpa here like this?
What is push?
No, I know
No,
until
no,
10.
not to Praneeth. In the classroom, there is one child who keeps doing like this, sitting in the class. When I'm teaching you guys, he keeps doing like this. I was
What is it
thinking
like?
it's a pushpa symbol or something else.
What's the moon?
Pushpa.
Moon.
Movie pushpa.
No, not movie.
Okay. Anyways, that's outside the syllabus. I was just trying to get your attention back. Don't do that because that gets me
It's
curious.
very fancy.
That gets me curious.
It's called mewing.
Stop that crap. I don't care about Gen Z, Gen X, Gen Y. Okay?
It's just
It's
Gen
only
Z.
math.
Okay.
Stop. It's only maths. Okay. All right. Now let's go to Praneeth. So sorry, Praneeth. I got distracted.
Right.
So table till 10, right? That's okay. I mean, see, even if you know table till 10 and you are accurate with that, we can keep on investing 5 minutes daily or 2 minutes daily to get to 11, 12, 13, 14. See, my expectation from you guys would be by the time we finish the school year 2024-25, meaning before the summer break starts next year, you guys should be all thorough with table up to 15. That is more than enough. Okay.
Alright.
So let's see. 9 9 ja,
81.
8 9 ja,
72.
7 5 ja,
35.
6 9 ja,
54.
11 6 ja,
66.
12 4 ja.
48.
See?
I mean, I know some. Like, just,
No, so see. So this is why I am testing your threshold, right? Not only yours, everybody's threshold, right? I'm trying to see, are you guys dead serious about what you said, or you actually know more than what you said? Yeah. All right. Let's go to Arav. So Pushpa has to say now. So table till
12.
12 8 9 ja, 12 9 ja,
91.
9 6 ja.
72.
9 6 ja. Hear the question first. Then you answer.
54.
54. 8 9 ja.
72.
12 7 ja.
84.
8 8 ja.
64.
12 6 ja.
72.
9 9 ja.
81.
Your turn. 12
15.
15. Okay. 15 4 ja.
60.
6 9 ja.
854.
14 3 ja.
42.
13 9 ja.
117.
6 8 ja.
848.
12 9 ja.
108.
Good job. Who is remaining now? Myra? Myra ready? Table till
13.
12 9 ja.
108.
13 6 ja.
78.
6 9 ja.
54.
12 7 ja.
84.
9 9 ja.
84.
13 9 ja.
107.
Okay, good job. Let's go to Lohit.
Until 12.
12. Lohit, do you mind turning on your video, beta? I've not seen you so far. This is your first class.
Yeah.
Yep. Okay. No, Lohit was there in the previous class also. I think you were there in the last class, right? Yeah. Okay. This is how we get to know each other more. Okay, table till 12.
Yeah.
6 9 ja.
54.
12 5 ja.
60.
6 8 ja.
48.
9 9 ja.
81.
6 9 ja.
54.
Okay, good job. So anybody? Okay, Sanvi. Sanvi's turn. Sanvi, ready?
Yeah.
Yeah, Sanvi is wondering what to do now. I'm stuck. Okay. Table till
12.
12. 11 9 ja.
99.
12 7 ja.
84.
9 9 ja. I think I asked you.
81.
81. 7 9 ja.
63.
12 7 ja.
You already asked that.
Say that again.
You already asked me that. It's 84.
Okay. Okay. 7 7 ja.
49.
Okay. 12 9 ja.
108.
Good job. But again, everybody has done good job. But what I would suggest is make sure that you still keep practicing for 2-3 minutes every day. I mean, 2-3 minutes of unproductive time you can find every day for sure, right? All right, let's go to Joel.
Yeah.
Table till
12.
12, 8 9 ja,
72.
7 5 ja,
35.
11 8 ja,
88.
12 9 ja,
108.
12 7 ja,
84.
13 3 ja.
36. 39.
Okay, no, that was a surprise question, but yeah, you did good. So you seem to be practicing table, but still, Joel, my request would be still find 2 minutes of your unproductive time every day and then practice tables, okay? Because tables will make life much more easier always.
Okay.
Yep. All right. So what are we going to learn today? No, I'll not ask you for sure. No, I'll not ask you for sure. No.
I'm very.
No, you have wasted a lot of your opportunity. Again, Araf, you have no opportunity for wasting everybody's time. Okay, first of all, what did we learn in the last class? Yep. Sanvi, hands down.
We learned about exponential growth and decrease.
Yes. Okay. Anybody having any questions with respect to what we learned? Araf, is it compulsory for you to talk always?
No, actually, I had a question like that I actually had for a pretty long time.
What is the question? Read it for me. Give me the question. I think you will, otherwise you will waste a lot of time. Which one?
Number 2 was.
Number 2. Okay, let me read it. A citrus orchard has 180 orange trees. A fungus attacks the trees. Each month after the attack, the number of living trees decreased by 1/3. If X represents the time in month and Y represents the number of living trees, which graph represents the situation over 5 months? What is the big deal?
Oh, 1/3. I was trying to make sure if it's correct because 1/3 we didn't like, do it. I added the 1/3 to the thing that I was correct.
No. So again, I'll probably take 5 minutes to explain this problem, okay? Anybody in the class who had similar doubts? Okay. So let me read the question once, okay? It says a citrus orchard has 180 orange trees, okay? It has 180 orange trees. Wonderful. A fungus attacks the trees. Okay, understood. Each month after the attack, the number of living trees decreased by 1/3. Every month, the number of living trees decreased by 1/3. Meaning decreased by 1/3. 1/3 of 180 is what? 1/3 of this is 60. Now the total number of trees has become 120. Every month this decreased by 1/3. So next month it is 1/3 of 120. Next month whatever number is after decrease, 1/3 of that. Okay. Listen. Use your ears and your brain more than your lips. Okay. So it says a fungus attacks the trees. Each month after the attack, the number of living trees decreased by 1/3. Every month after the attack, the number of trees decreased by 1/3. Meaning, whatever is the number of trees in the beginning of the month, after the fungus attack, that decreases by 1/3. Okay? Now, it says if X represents the time in months and Y represents the number of living trees, which graph best represents the situation over 5 months? Now, this is X and Y. X represents the time, meaning 1 month, 2 month, 3 month, 4 month, 5 month. 1, 2, 3, 4, 5. Let's say this is, okay, so this is 20, 40, 60, 80, 100, 120, 140, 160. Okay? It says the orchard has 180 trees. So it has 180 trees. In the beginning, before we start counting, okay, this has 180. Now you look at all the options here. What do you see here? Every graph is starting from 180. So this part is fine. All the 4 options are okay. Now, says after every month when the fungus attack happens, it decreases by 1/3. Meaning decreases by 1/3. Meaning 1/3 of whatever you have that is taken out. So 1/3 of 180 is what? 60. So it becomes 180 becomes 160. Sorry, minus 60 is out. It becomes 120. Look at the graph. After first month, whichever is around 160, so it is 180, it becomes 160. After first month. After second month, what will happen? 120, 1/3 of that will be gone. So 1/3 of that is what? 40. So 120 becomes 120 minus 40. That is 80. So 80 is here. Oops. 6. This is here. Second month is. See, it is coming down drastically. So whenever you see this kind of a graph, it is going flat, that will be out. You can probably, you don't have to worry about all that, okay, complications. Simple thing is, after first month it became 120, after second month it became 80. After third month what will happen? 1/3 of 80 will be gone. 80 1/3, that is somewhere around 27. Yeah, around 27. So 80 becomes this, almost like 53. So third month will come to this point. So look at the graph. In this graph, where you see that kind of a thing, that is what will be your answer. The one that you have picked up, this is not correct. Because you have to see, again, you have to look at this calculation and pick up what is the value after first month. Put that in the table.
It's answer choice B.
Yep. Look at the table first. Make the table first month, second month, third month, fourth month, what will be the value, and fit that in the graph and see which one is closest to that. That will be the option. The one that you have picked up, that is not right. So again, whatever I did, there was nothing complicated or cryptic about it. It was a simple exponential growth or decrease problem where the question said that in this orchard it decreases by 1/3 in every due to fungus attack, and then you have to put the value and pick up which graph is the most relevant one. Okay, that's the only way, and the graphs are very intuitive. I mean, you have to just look at every month what is the value and which one is closest to the table that you can draw out of it. Okay. So before I move on to the next topic, any questions? Anything that was not clear to you guys? No questions? Surprising. Anybody? Sanvi, Dikshita, Lohit? Yeah. No questions? Okay. So let me pick up the topic. I have a topic in my mind. So we'll talk about guys, don't do that. Let's talk about irrational numbers.
Rational numbers?
Irrational numbers.
Irrational numbers.
And that irrational number doesn't need an irrational behavior either. Do you know what is irrational behavior? What is rational behavior? When you behave in an expected way, that is rational.
Like dancing?
Hmm?
Like dancing?
What is it? Okay. I should not have started the discussion itself. So let's talk about irrational numbers. Anybody in the class, except Arav for now. You showed irrational behavior, so that was not the question. So, anybody, any guesses? What is irrational numbers? Any? Okay.
By the Greek term, not rational numbers?
Okay, that's not good enough. Yes, Anvi.
A number that goes on forever that doesn't repeat.
Okay, I'll take it as one parking point. Any other definition? Irrational numbers. Yeah, Anirudh. You're talking on mute.
A fraction of a decimal that goes on forever.
Okay, but let's say 1/7. That might go on forever. 22/7. The pi also goes on forever. But do we call this a irrational number? No.
It's not a decimal, not a fraction, nor a...
Okay. So let's go back to our memory lane, okay? What we have learned in the past. And something that you would certainly not want to see, but I will force you guys to see.
Okay. I'm not seeing.
Go to the tree. There's a ghost lying there. See
That
that?
we can talk.
Okay, let's not put any effort for wasting time. This is the number line.
Okay.
No, okay, in between. That disturbs. I have told you before. Right? 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. Okay? This is my number line, regular standard number line that you all would have seen 100 times before, maybe 1,000 times. Now, 1, 2, 3, 4, 5, 6, and I can go on. These are called
Positive numbers.
natural numbers. Or positive numbers is fine, but that's not a mathematical definition, okay?
Would positive work?
No.
No.
I'm saying this is natural number. Okay? Now, take 0 also into account.
Whole numbers.
This is called whole number.
Whole numbers.
Okay? Now, take integers also in the gang.
You just said it.
Or numbers.
Integers. Yep?
So, can I compare this to like the line segments and that stuff?
So, don't mix too many things. Let's keep it simple for now. Arab, let the teacher do his job. Don't try to rush for becoming a teacher. Let me do my job. Don't mess with each other. Focus on what you have to learn, okay? No matter whether he's your brother or your friend or whatever, you will get your SAT score for your performance in the examination hall. So focus, be very self-centered when it comes to learning something, okay? Now, so one to, no, as far as you can think of, these are called natural numbers. You include 0, this whole set becomes whole number. You include negatives also, that is integers. No doubt so far? Now, add other members in the family. We have not talked about the things in between 0 and 1, 1 and 2, 2 and 3, 0 and minus 1, 1 minus. Let's look at 0.5 or 1 by 2. 1 by 2. This is a fraction. Yeah? Minus 1 by 2 also is a fraction. 1 by 2 is a fraction. 3 by 2 is a fraction. 2 by 9 is a fraction. Whatever, right? And likewise, you go on the negative side also. Minus 2 by 6 is a it's a fraction, but all the positive ones we call them as fraction. You include the negative one also. This whole thing is called real number or sometimes rational number. So, in summary, if you are only looking at the complete numbers, this is natural number, include 0, whole number, include negatives, the integers, this is fraction or real numbers. And then when you talk about rational number is the father of all. Everything together is called rational numbers.
I didn't learn rational yet.
Now you're learning, focus on that.
Okay.
Okay? So, rational number is any number that you can rationally describe. Yeah? Or any possible type of number that you can deal with, be it fraction, be it whole number, be it negative, be it 0, all included, be it mixed numbers. Okay? Is called rational number. Yeah? Or I can give you a very lame definition of that. So, Anirudh, you are asking something? Your hand is raised. Okay. Alright. So, any number that you can describe or put that in a form of a fraction, be it positive, be it negative, is called rational number. Don't, I mean, you guys anyways don't have to give the definition of numbers anywhere, but I'm saying for memorizing it for yourself. Any number, be it this, be it this, be it this, be it this, any and every number that you can represent in the form of a fraction. This you can write as a fraction 3 by 1. This is anyways a fraction. This is anyways a fraction. This is a mixed number which will convert to a fraction by 4 2 is 8 plus 1 9 by 2. So every number that you can write in the form of a fraction is called rational number or real number. Okay. Now, but that was not the agenda. We were trying to learn irrational numbers, right? So I've been misguiding you this far, but that misguiding was to tell you that these are the paths you don't have to go. So what is irrational number? Everything that we talked about, that is not irrational number.
A decimal is
Isn't that irrational?
Even decimal or percentage. 3.1, it can be written as a fraction, 31 by 10. It's a rational number. Yep, yes, Anvi. Sorry, yes, Dikshita and Anirudh, you guys have a question. Yep.
A number you can't describe as a fraction.
Say that again.
A number you can't put as a fraction.
Any number that you can put as a fraction is a rational number. Now the question is, what is a rational number? Yeah, Dikshita, you had a question. You had raised your hand as well.
I was about to say that.
Okay. So I think I missed you guys. So Anirudh, you might want to repeat.
So I said that an irrational number is any number you can't put as a fraction.
Okay, so an irrational number is something that you can put as a fraction. That's what you're saying. Okay. I heard can. Yeah, Anirudh. Arav. Yeah, you were saying something. Yeah. Okay. So any number that you can describe as a fraction is a rational number. Understood? Any number that you cannot put as a fraction is a rational number. But what are those numbers? Where do you find them? Can somebody give me one example?
Ratio?
Ratio is nothing but a fraction. Yep, yeah, Anirudh.
Pi.
What is that?
Pi.
Pi is a fraction.
But it's not accurate. Like it's
No,
not.
12 by 7, 22 by 7 is the value. Now when you convert that to decimal, this becomes 3.1416 and it goes on. But then, this is because we are trying to convert it to decimal, that's why you don't get the accurate value. But as a fraction, this is the value. Nobody can deny pi's value being 22 by 7. Yep.
E.
E is, again, it's more like an exponent, right? So I would, normal. Irrational number doesn't have to be an erratic behavior, normal.
Rational, can it be infinite?
No. See again, infinity can be there on the number 9 also. When you go on the positive side, you can go to infinity.
Exponential.
Okay. I think you guys have exhausted your guesswork. Okay. Anybody else? Joel, you want to give it a try? Tell me if you have heard of irrational number. Okay.
What
I'm sorry?
give an example for a rational number?
Irrational number. I'm just trying to figure out if you guys can give me a valid example for an irrational number.
0?
No, that's a whole number. Pretty much a part of a real number group or a rational number group. Yes, Anvi.
Pi.
Pi? No, pi is not a irrational number. Pi is 22 by 7. That's pretty much a fraction. Yep, Praneeth.
Square root of 2.
Spot on.
Actually,
Square root. Square root of anything that doesn't convert into a natural number or real number.
Can it be under root? Or cube root?
We'll see. We'll come to that. Yeah. Yeah, Lohit.
Numbers that go on forever.
I mean, as long as, see, like, pi is a classic example. 22 by 7, that goes on forever. You will not get an accurate value. But that is still can be converted into a fraction form. So that's why that we would not consider. But square root is one case. With a square root of a prime number, that's what I would put it. Okay. Square root of a prime number which cannot give you exact value as you know, as a natural number or a real number, that is what would be called an irrational number. Yes, Sanvi.
The golden ratio.
Say that again.
The golden ratio.
And what is that?
That's a Fibonacci equation.
I think, I don't know. I heard it in math class.
Okay.
I think it's also known as pi or something.
Okay, so let's.
I actually have a good one.
Huh?
No value.
Okay.
Stop him.
Got that? Yeah? I mean, you don't want me to repeat? Yeah? Okay.
Fibonacci series.
Waste of time. Okay, stop it there now. Now, let's look at some numbers, okay? Yeah, Anirudh.
Wait, but isn't 22 by 7 like an approximation of pi?
No, it's exact value of pi, 22 by 7. 3.14 is the approximation. Okay. Now I will teach you guys chicken egg story real quick.
Oh yeah.
Most of you know that. 22 by 7. Meaning divide 22 by 7. That's what you're trying to do. 7 3s are 21. What is remaining? 1. Decimal is your chicken which keeps on laying one egg at a time. So you put the decimal as a chicken here. Lays one egg here. 7 1s are 7. What is remaining? 3. 7 4s are, again, decimal, your chicken lays one more egg. 7 4s are 28.
I have a lifetime of supplies.
2 remaining. Your chicken lays one more egg. 7 2s are 14. 14. 6 remaining. Your chicken lays one more egg. 7 8 are 56. And it will just go on. But this is only because you're trying to convert a fraction to a decimal and you don't get the accurate value. That's okay. But this will not be qualified for being called an irrational number, because anything that can be converted into accurate fraction, that is not an irrational number. And so yeah, let's go to what we want to learn.
That's what I said.
Yeah, we're learning incomplete ratios.
Then okay. Now let's see. Do you know what do you mean by square root of anything? No, you guys will not get a chance right now. Let's see on the screen. Do you guys know what do we mean by square root of anything? No? Okay, Praneeth.
To divide a number by itself. For example, wait, no. Whatever times another number has a result. For example, the square root of 16 is 4, so 4.
Yeah. It's a reverse of square, basically, if I can put it that
Yeah.
way.
I was gonna say.
Yeah.
Is that the understanding for you guys also?
Yeah.
Okay. So 3 squared is 9. Square root of 9 will be 3. And how I will look at it mathematically? Square root of 9 means I will put this in a bracket saying 9 to the power 1 by 2. Okay? And then this becomes 9 becomes 3 squared. I can write it like this. And this is how I will do the calculation.
1/2.
Johnny, we can do power 1/2 as soon as like we can.
Hey, let the teacher do his job. And whatever you have to teach your brother, you can do it at home.
I don't like it.
Okay. So here, if you look at this calculation, right? If I have to find out the square root of 9, I can write this in the form of exponents. I can write this as 9 to the power 1 by 2. Okay? Square root is 1 by 2. If somebody says find out the cube root of 9, that means 9 to the power 1 by 3.
So the cube will always be a fraction.
Keep it there. Keep it paused. Focus on what I teach. We are going in different directions.
I got confused because you
Okay.
put the exponent up there.
Okay. Let me complete, okay? And then you try concluding from that. If I say cube root of something, quadratic root of fourth root of something, that is nothing but. Now if you relate this, right? When I said square, it was power 2. If I am saying square root, it is power 1 by 2. If I said cube, I meant power 3. When I said cube root, I meant power 1 by 3. See, that is the relationship here between square and square root, cube and cube root. Are you guys able to relate?
Yes.
Make sense?
What does it mean by the 4? What is that called?
Fourth root.
That's
The
called.
fourth root.
That's called a
You
cube.
can have 10th root also, and that will translate into this to the power 1 by 10. That's it.
Could a cube root be a fraction?
Waste of time, will not go there. If you have any question like that, you put that in a notebook and you try doing it like a regular math. I mean, will a cube be a fraction? What kind of a question is that? Something. Will this be a fraction? Why not? It can be a fraction.
No, I meant like if the 3 is 1/3, will it be a fraction on the cube root?
What?
Put it in a notebook and then you will know the answer. I mean, try doing the scratchbook by yourself and you'll find the answer, okay?
Do it yourself.
See, simple thing. Whatever idea comes to your mind, put that in a notebook, because we are not doing any air math.
Can I go back to my
Yeah, sure. Now, coming back to this one, okay? Let's say, if I say find out the square root of 9, okay? You know that I can write this as 9 to the power 1 by 2. And 9 I can write as a square of 3. And from exponents you have learned that if x to the power a in bracket to the power b, this becomes x to the power a times b. Yeah. So here this becomes 3 to the power 2 multiplied by 1 by 2. X to the power a to the power b. X to the power a to the power b becomes x to the power a times b. X to the power a times b. And this becomes 3. So this square root of 9 gave you exact 3. And this can become a rational number. 3 by 1. Yeah. Now, if you end up doing something like this, square root of 2. Now, that means 2 to the power 1 by 2. Now, is 2 a square of any number?
No, because it's a prime number.
Right? Any prime number cannot be written as a square. If I have a 9, that's not a prime number because 3 times 3 or 3 squared. Any prime number, if you have to find out the square root of that, you cannot convert it into the form of a square to get a... Wait, let me go with my chain of thoughts, and then towards the end when I conclude, if you have a doubt, you can ask. We are not doing a debate, remember that. So, if you have to try finding a square root of 2 or a square root of 3, you don't know what to do. You cannot convert this to a rational number. You cannot convert this to a fraction. You cannot convert this to a whole number or natural number. If you have to find out square root of 4, then you know that this becomes 4 is nothing but 2 squared. 2 to the power 1 by 2. It becomes 2 to the power 2 into 1 by 2. That is 2 to the power 1. And this is a rational number. See, this is a rational number because you could convert it to a fraction or a natural number. You cannot convert this to a natural number. You cannot convert this to a natural number either or a fraction. These are called irrational numbers. Yes, Dikshita.
Why can't we like convert the 3 1 by 2 as like a square root?
So because 3 1 by 2, 3 to the power 1 by 2, you have to find out. Meaning 3 has to be a square of something. Then only you can convert this to, you can break it down. Look at this 4. 4 you can write as 2 squared. 4 can become 2 squared. And then you can break it down, it becomes 2. But 3 is not a square of something. 2 is not a square of something. So is the case with 5 also. 5 is also not a square of something. So you cannot get rid of this bracket, this square root thing. If it's 9, you know that okay, 9 becomes 3 squared. So that means this is 3. Or you will say 3 squared to the power 1 by 2. It becomes 3 power 2 into 1 by 2. That is 3 power 1 or 3. Or you can write this as 3 by 1. It's a rational number or natural number. But in case of 2, 3, 5, 7, all the prime numbers primarily, okay? All the prime numbers. If you find out the square root of them, you cannot get to a form of a natural number or a fraction. And that is why they are called irrational numbers.
Okay, sir.
Now what is your question?
Well, yeah, so you said...
When you had to be awake, you were sleeping. When you had to sleep, you were awake.
So, actually, it actually doesn't have to be it can actually be a multiple.
No, you are not getting the right argument. I don't think I could understand what you were trying to say, and that was not making much sense to me for sure. Say that one more time.
Never mind.
No, say that one more time. I'm forcing you to think.
I'm good.
You are not good. You have to learn. Okay. Alright. So, the basic definition of irrational number, or basic understanding of irrational number is this. When a number cannot be converted into a natural number or a fraction or integer, that is called irrational number. And a brief summary of that is, most of the prime numbers are irrational numbers. But the question is that only prime numbers are irrational numbers?
Not really.
Not really. If you look at 12,
You look at 9.
You look at, no, 9 is it's not a rational number for sure. Square root of 9 is not irrational by any means.
Oh, wait.
You look at 12.
12 is even though.
Doesn't matter. If you are looking at 12, is this rational number? No. This is not a, is there a prime number? Yes. But square root of 12 is not rational number.
What about 13?
I factor
Go on. 13 is anyways a prime number. Square root of that will be.
Nothing.
multiple.
Yeah, Dikshita.
Isn't it 12 like prime number?
12 is not a prime number because 12 can be divided by Arav and Adi. Can you guys keep the discussion for whom?
Okay.
Okay. So 12 is not a prime number because 12 you can write as 6 times 2 or 4 times 3. What is the definition of prime number? Any number that can be divided by itself or 1. 12 can be divided by 6, 12, 2, 4 and 3. So it's not a prime number. But is 13 a prime number? Yes. A number like 13 is a prime number because it can be divided by only 13 and itself. 13 and 1. Okay? So 12, even if it's not a prime number, but square root of 12 is an irrational number. Because square root of 12, what does it mean? 4 times 3, that means 2 squared into 3 square root. So square root of 2 will come, make it 2 square root of 3. So this part came out, 2 into square root of 3. Square root of 3 is a rational number. Any number you multiply with a rational number remains irrational. Yep. Now,
We're going to talk about this more tomorrow.
obviously we'll do a little bit more of operations with irrational number because what is the compelling need?
Oh, I was going to ask a question.
Now see, you have that instinct of raising hand.
I was supposed to wait for him.
If while teaching, if I keep raising hand like this, tell me how beneficial it will be for everybody.
We'll have homework.
Of course, why not?
When was the last time you did not have homework?
It was
Waste of time. Stop it there. Yeah, Dikshita.
So 13 is the prime number, right? So how can it like be a square root?
No, so that's the thing. If you try finding out square root of 13, you will never get a valid answer. You will not get a 3 or a 4, which you can represent as a fraction. That's why it's called irrational number. Irrational, see,
So
give me a rational point of view. What does it mean? Meaning something that is reasonable, that is something understandable, that is something doable.
Can we do 16?
This is irrational, meaning somebody is forcing you to do something that you will not be able to find out accurate answer for. That's why these are called irrational. And that's why all the numbers, when the square root of those numbers doesn't give you a very conclusive answer or easy to find answer, that's why those are called irrational numbers.
Okay, sir.
It doesn't mean that we will not deal with irrational numbers. We will. Let's say somebody says, find out this into square root of this. We'll do more operations with irrational numbers in the class tomorrow. But if you look at this, two irrational numbers multiplied with each other might get rid of this. This gets you 3. But irrational number 6 and irrational number 5, if you multiply them, it gives you another irrational number. So there is no one thumb rule. Ultimately, but only thumb rule is if you multiply irrational number with a rational number, this will never be a rational number. It will always be a rational number. It's like multiplying minus with a plus. It will always give you minus.
But if you get a minus with
If you multiply minus with a minus, you might get a plus. You will always get a plus, but in this case, irrational versus irrational, same number gives you a rational number, but two irrational numbers which are different will never give you a rational number. Okay. Anyways,
Oh, that makes so much sense.
I thought
so now we have just touched the basic concept of what is irrational numbers. Okay. and we'll talk more about the operations and the different theorems or the rules that we need to be aware of by practicing them more in the class tomorrow. That will get us little more closer to what is a rational number and how do we deal with them. While just by looking at the rational number, it looks a little scary, right? I mean, how do I find out square root of 2? I mean, do you really need to find out square root of 2?
No, because there already is a square root.
Right? So, do we really need to find out the value of that? There are certain scenarios where you'll be able to find out. There are certain scenarios where you will not be able to find out. And you have calculators for doing it. So, we'll look at what are the different enablers or the different type of operations that we need to be aware of. And then only we'll conclude whether we have understood it enough or not.
Okay.
Yep?
Yeah.
Alright? Lohit? Any questions? Joel? Did I make enough sense?
Yeah.
Okay. Praneet? Was this easy to follow? Myra, Sanvi?
Yeah.
Yeah? Okay. Tanu? With me?
Yeah.
Okay. Dikshita, no questions?
No, sir.
Wonderful. See, that's why I always claim I'm the best. I'm just kidding.
Can I